Hey guys, this is the first video of a 3-part tutorial where I'll share how to calculate how long and how far a scroll rect will scroll after the user ends a swipe, assuming inertia is enabled. Although I'm explaining this technique in the context of a scroll rect, the same calculations can also be used for other things, such as a spaceship decelerating to a complete stop. In this first video, I just explained how the scroll rect deceleration equation works. So if you're already comfortable with that, feel free to skip to the next video. The first question we need to answer is, what equation does Unity use for scroll rect deceleration? If you take a look in the late update function of the scroll rect source code, you'll find this line of code. So what exactly is this doing? First off, deceleration rate is normalized between 0 and 1. You can think of it as the percent of velocity left over after 1 second. 0 makes it stop immediately, while 1 means it would continue scrolling forever at the same velocity. 1 is technically not defined, it should be less than 1, but you get the idea. For example, if the initial velocity is 8, and we want the velocity to be cut in half at each second, we end up with a series like the following. Here, the deceleration rate is 0.5. Conceptually, we're saying the velocity, delta times seconds in the future, is equal to the current velocity times something. For the trivial case of delta time equals 1 second, we simply multiply by the deceleration rate. But as we all know, delta time varies from frame to frame. So let's say delta time is 3 seconds next frame. How do we go straight from V1 to V4? We can't skip those steps in between, so we multiply by the deceleration rate 3 times. Which is exactly what the POW function is doing, except generalized for any delta time. Let's graph this equation for a quick visual. I like using this Desmos graphing calculator site. As you can see, the velocity starts with a steep decline and gradually flattens out, approaching but never quite reaching 0, which is why Unity just sets the velocity to 0 if it's less than 1. And as expected, the velocity at each second matches our example series. 4, 2, 1, and 0.5. Now that we've demystified the equation for deceleration, we should be able to use it to derive the equations for distance and duration. In the next video, we'll do just that.